Hello, everybody. In today's lesson, lessons 3.3, our topic is compare and order decimals. And by the end of the lesson, you should be able to answer the essential question that how can you use place value to compare and order decimals? Okay. And we're on page 117 of the fifth grade Go Math textbook. So let's look at the unlock the problem. The table lists some of the mountains in the United States that are over 2 miles high. How does the height of Cloud Peak in Wyoming compared to the height of Boundary Peak in Nevada? So again, we have mountain heights in the table. We have 4 mountains and the states in which they are located. And these are their heights in miles. So how can we compare these? So it says, how does the height of Cloud Peak in Wyoming compare to the height of Boundary Peak in Nevada? So we're just looking at these two, right? Okay, so one way we can compare those is to use place value. And so in that case, we would just line up the decimal points. Start at the left and then compare the digits in each place value position until the digits are different. Okay, well, all right. So we lined up the digits. Okay, so we made sure that um, the ones are under the ones, the tenths are under the tenths, the hundredths are under the hundredths, and the thousandths under the thousands. So the first one is compare left to right. So let's compare the ones. So that's the biggest digit in or place value in this number. And they're both twos. No, well, that doesn't help us at all, right? Okay, so let's move to the digit to the right. And let's compare the tenths. Oh, well, they're both fours. Okay, so 4 tenths equals 4 tenths. That's still not going to help us. All right, let's keep going. Let's go to the right and let's look at the hundredths. Oh, okay, here they are different, right? So 9 hundredths is greater than 8 hundredths. So since 9 is greater than 8, then 2 and 495 thousandths is greater than 2 and 488 thousandths. Or we could also say 2 and 488 thousandths is less than 2 and 495 thousandths. So the height of Cloud Peak is greater than the height of Boundary Peak. Okay. Well, another way we could do that is to use a place value chart. And so your place value chart would have the greatest digit to the left, and in this case, they're ones, then tenths, hundredths, thousandths. Okay, and this time they want us to compare the height of Cloud Peak to Wheeler Peak. And Wheeler Peak is in New Mexico, and it says that it is 2 and 493 thousandths. Okay, so you would put both numbers in the place value chart, and we would still just compare place values until you find something that's different. Well, the 2 ones equal 2 ones. The 4 tenths equal 4 tenths. That doesn't help. 9 hundredths equals 9 hundredths. But 5 thousandths is greater than 3 thousandths. So since 5 is greater than 3, then 2 and 495 thousandths is greater than 2 and 493 thousandths. Or the opposite, right? 2 and 493 thousandths is less than 2 and 495 thousandths. So the height of Cloud Peak is greater than the height of Wheeler Peak. Okay, so let's continue. Page 118. You can use place value to order decimal numbers. So example, Mount Whitney in California is 2 and 745 thousandth miles high. Mount Rainier in Washington is 2 and 729 thousandths miles high. And Mount Harvard in Colorado is 2 and 731 thousandths mile high. Order the heights of these mountains from least to greatest. Order least to greatest. Which mountain has the least height? Which mountain has the greatest height? Okay, well, again, you can use a place value chart or line up the decimals. So lining up the decimals is either way is fine. It's just there's not one way that's actually easier than the other. So just line up the digits. Make sure you identify which ones are which. So Whitney is 2 and 745 thousandths. Rainier is 2 and 729 thousandths. And Harvard is 2 and 731 thousandths. All right, so they're the same number of ones, right? 2, 2, 2. So let's circle the tenths and compare. So we have 7 tenths, 7 tenths, 7 tenths. Well, those are all the same. Okay, well, let's keep going. Let's underline the hundredths this time. So 4 hundredths, 2 hundredths, 3 hundredths. Okay, those are all different, right? So that would help us. Which of those three numbers in the hundredths is smallest? The 2, right? So 2 hundredths is less than 3 hundredths, and 3 hundredths is less than 4 hundredths. So the heights in order from least to greatest would be 2 and 729 thousandths, 2 and 731 thousandths, and the greatest would be 2 and 745 thousandths. So blank has the least height. Which one was the smallest? 2.729. So Mount Rainier has the least height, and Mount Whitney has the greatest height. Okay, simple as that. So let's keep going. Try this. All right, this time let's use the place value chart. What is the order of 1 and 383 thousandths, 1 and 321 thousandths, 1 and 456 thousandths, and 1 and 32 hundredths from greatest to least? Well, what we have to do first is write each number in the place value chart. So 1 and 383 thousandths is already written for us. Let's write 1 and 321 thousandths. Then 1 and 456 thousandths. And 1 and 32 hundredths. Compare the digits beginning with the greatest place value. So that means we would compare the ones. There's no difference in the ones. So now let's go to the tenths. Okay, well, all of them are 3 except for the one that's 4 tenths. Well, 4 is greater than 3's, right? So that's the biggest one. So the greatest number is 1 and 456 thousandths. That's the greatest. We have to find the order of these from the greatest to the least. All right, so we found the greatest. But I can't find what's the next one in order because they're all 3 tenths. So let's go to the hundredths with the remaining ones. I don't need to do anything with the 1.456, 1 in 456 thousandths. We've already identified that. So just the 3 tenths ones. So we have 8 hundredths, 2 hundredths, 2 hundredths. Well, 800 is clearly bigger, right? So that's the next larger. So the next greatest number is 1 and 383 thousandths. All right, let's go to the thousandths. So we have 2 numbers left. We have a 1 and nothing. Well, nothing is actually 0, right? Okay, so I can put a 0 there, and 1's greater than 0. So the next one would be 1.321. The smallest is 1.32. All right, so the order of these numbers from greatest to least. 1 and 456 thousandths, 1 and 383 thousandths, 1 and 321 thousandths, followed by 1 and 32 hundredths. Use the place value chart to compare the two numbers. What is the greatest place value position where the digits differ? Okay, well, they both have 3 ones, so those are the same. 4 tenths, 4 tenths, those are the same. Hundredths, okay, so there we have a difference. 7 is greater than 4. So let's compare them. 3 and 472 thousandths is greater than 3 and 445 thousandths. Well, let's compare these. Okay, so I have 4 and 4. That doesn't help any. 5 tenths, 5 tenths. That doesn't help. 6 hundredths, 3 hundredths. Okay, well, 6 hundredths is greater than 3 hundredths. So number 2, that's greater than. Okay, number 3. The 5s are the same. 6 tenths, 6 tenths. Those are both the same. 4 hundredths, 4 hundredths. 0 hundredths, 0 thousandths, 0 thousandths. These two are equal. Number 4. 8 and 8 doesn't help. 6 tenths, 6 tenths, that's the same. 7 hundredths, 3 hundredths. 7 is greater than 3 hundredths. Okay, name the greatest place value position where the digits differ. Name the greater number. So we have 3 ones, 3 ones. 5 tenths, 5 tenths. 7 hundredths, 6 hundredths. Which one's greater? The 7 hundredths number. So 3.579, which we read as 3 and 579 thousandths. Number 6, the 9s in the ones place are the same. 5 tenths, 6 tenths. Okay, well, we already have a difference. We have a difference in the tenths place. 6 tenths is bigger than 5 tenths. So 9 and 637 thousandths. Number 7, the 4 ones are the same. The tenths are the same. The hundredths are the same. The thousandths are different. So 9 is greater than 2. So 4 and 159 thousandths is the greater number. Okay, number 8. Order these numbers from least to greatest. So I'm going to rewrite these so that they're stacked on top of each other so I can compare place value. Okay, I'm looking for the smallest number first. So the 4s, the 1s doesn't help. Okay, here we have 0, 3, 8, 0. Okay, well, the zeros are the smallest one. So let's go to the next place value to see which one of those is biggest or smallest. So 8 is bigger than 3 hundredths. So the smallest number is 4 and 38 thousandths. The next smallest is 4.08. Okay, so we've used those two. Now, which one's smaller between 4.3 and 4.8? 4.3. So the largest number is 4 and 803 thousandths. Okay, number 9. Again, line them up. We want to find the least value. The ones are the same. That doesn't help any. 7030. So the 2 zeros are the smallest numbers. Let's go to the hundredths. 3 is less than 7. So our smallest value is 1.037. The next smallest is 1.073. Okay, now we can go back to the tenths to compare the final two. 3 tenths is smaller than 7 tenths. So 1.37, and the largest is 1 and 703 thousandths. Simple as that. All right, number 10. All right, if we were comparing these by stacking them, the eighths the same, the 7 tenths are the same, the 200ths are the same, and then this has 0 thousandths, but so does this. So these two are equal. If there's nothing after a digit in the decimals, it's 0. Okay. All right, 11. So 5.4 compared to 5.243. Well, the 5s are the same, but 4 tenths is greater than 2 tenths. So 5 and 4 tenths is greater than 5 and 243 thousandths. 1.036, 1.306. The ones are the same, but the 0 is less than the 3 tenths. So 1 in 36 thousandths is less than 1 in 306 thousandths. Okay. So if we line up the decimal values, the 2 ones are the same. 5 tenths and 7 tenths are different. 5 tenths is less. So 2 and 573 thousandths is less than 2 and 753 thousandths. Number 14. 9.300 compared to 9.3. Well, the ones are the same. The tenths are the same. There are no hundredths, and there are no hundredths here. There are no thousandths. There are no thousandths. These two numbers are the same. Okay? They have the same value. Number 15. 6 and 76 hundredths compared to 6 and 759 thousandths. Comparing the place value, the ones are the same. The tenths are the same. The hundredths are different. 6 hundredths is greater than 5 hundredths. So 6 and 76 hundredths is greater than 6 and 759 thousandths. All right, 16. Order these numbers from greatest to least. Greatest to least. So we're looking for the number that is the greatest. The 2's are all the same. 0, 7, 0, 9. The 9 is the greatest. So 2.97. The next greatest is 2.714. And then we have zeros left. Okay, well, the zeros are the same. So let's go to the hundredths. We have 0 hundredths and 9 hundredths. So 2 and 9 hundredths, and the smallest is 2 and 7 thousandths. Okay, 17. 0.386, 0.3, 0.683, 0.836. And again, we want to find the greatest number. The zeros don't help. So let's go to the tenths. Okay, the 8 is the greatest. So 8 and 836 thousandths. The 6 is different than the 3, so that's greater. Okay, now the 3s, that didn't help. Those are the same, so we have to go to the hundredths on those. That one's 8 hundredths, and this one's 0 hundredths. So 0.386, and the smallest is 3 tenths. 18. Line up the decimal values. Okay, they all have 5s. The tenths, 2 tenths, 4 tenths, 3 tenths, 2 tenths. All right, so the greatest is 5 and 43 hundredths. The 3 is greater than 2. So 5 and 340 thousandths is the next greatest. 2 tenths, 2 tenths. Those are going to be the same, right? So we have to go to the hundredths. 4 hundredths compared to 0 hundredths. All right, so we know that 4 hundredths is greater. And our smallest number is 5 and 209 thousandths. 19. 0.678, 1.678, 0.587, 0.687. Okay, well, that one's clearly the biggest because it has a 1 in the ones place. 1.678. Okay, the rest are zeros, so that doesn't help. So let's go to the tenths. 6 tenths, 5 tenths, 6 tenths. Okay, well that we know which one's the smallest is 0.587 or 587 thousandths. But we want to go from greatest to least. So I have to find which one is smaller between these two. So let's go to the hundredths, 7 and 8. Okay, 8 hundredths is bigger, so the next greatest is 687 thousandths, then 678 thousandths, and the smallest is 587 thousandths. Okay, number 20. Find the unknown digit to make each statement true. 3 and 59 hundredths is greater than 3 and 500 and something 1 thousandths, which is greater than 3 and 572 thousandths. Well, when we compare the ones, they're all the same, 3, right? When I look at the tenths, I have 5 tenths, 5 tenths, 5 tenths. When I go to the hundredths, I have 9 hundredths, some number missing, and 7 hundredths. Well, the only way for this one to be bigger than this one is for it to be 8. And 9 hundredths would be greater than 8 hundredths. So 8. 21. 6, 6, and 6. So the ones are all the same. 8 tenths, 8 tenths, 8 tenths. 3 hundredths, 3 hundredths, 3 hundredths. 7 thousandths, missing digit, 5 thousandths. So what number is 7 greater than, but that number is greater than 5? That's 6. Okay, 6 is the only number that would work there. All right, and number 22. 2 ones, 2 ones, 2 ones. Okay. 4 hundredths. 4 tenths, some tenths, 4 tenths. Well, that has to be a 4. Because it couldn't be a 3, because then 45 wouldn't be less than that. If I had a 5, then this one couldn't be less than that one. So it's got to be a 4. All right, page 120. Use the table for numbers 23 through 26 All right, so we have mountains over 3 miles high. We have Mount Blackburn in Alaska, Mount Bona in Alaska, and Mount Steele in the Yukon. All right. In comparing the height of the mountains, which is the greatest place value where the digits differ? All right, we'll just compare the digits, correct? The ones are all the same. The tenths, 1/10, 1/10, 1/10. Those are all the same. Hundredths, 0 hundredths, 3 hundredths, 5 hundredths, hundredths. All right, 24. How does the height of Mount Steele compare to the height of Mount Blackburn? Compare the heights using words. So Mount Steele, Mount Blackburn. Mount Steele is 3 and 152 thousandths. Mount Blackburn is 3 and 104 thousandths. Well, if we're comparing these, the ones are the same, the tenths are the same, the hundredths are different. So 3.152 is a bit larger. So Mount Steele height is greater than Mount Blackburn's. 25. Explain how to order the heights of the mountains from greatest to least. Well, what do? We go ones, the largest place value, to the smallest place value. So since the ones are all the same, we would look at the digit to the right. Okay, when we looked at the tenths, they were all ones. Okay, we want greatest to least. So 5 is greater than 3, which is greater than 0. So the heights of the mountains from greatest to least are Mount Steele, Mount Bona, Mount Blackburn. So basically all you're doing here in explaining on number 25 is what have we been doing in this lesson? We've been comparing the place values left to right until we find the largest place value that is different. All right, 26. What if the height of Mount Blackburn were 500th mile greater? Would it then be the mountain with the greatest height? Explain. All right, so what they're saying is, what if Mount Blackburn was not 3 and 104 thousandths, but 154 thousandths? Would it then be the greatest mountain in height? The threes would still be the same, the ones would still be the same, the fives would still be the same, but the thousandths, the 4 thousandths would be greater. So, yes, it would be. All right. So would it be the greatest? Would it be the mountain with the greatest height? Yeah, because this it would then be 3 and 154 thousandths. Mount Still would be 3 and 152 thousandths. Well, that would make Mount Blackburn 2 thousandths of a mile taller. Okay. 27. Orlando kept a record of total rainfall each month for 5 months. All right, so he kept track from March to July. And we have to put these from the least to the greatest. So let's see if we can find the smallest one. So if we go with just the ones, I do see that June and March have threes, which is less than 4. So March or June is the least. So let's go to the tenths to compare those. So we have 7 compared to 0. Well, 0 is less than 7. So June is the least, followed by March. All right, so we're done with those two. Now let's go to April, May, and July. So April, May, and July all have 4. We're still looking for the smallest of these because we're going least to greatest. So 4 tenths, 0 tenths, 0 tenths. Okay, so April is the largest. So between May and July, which one's smaller? 9 hundredths, 4 hundredths. 4 hundredths is less than 9 hundredths. So July and then May. And the largest is April. Okay. All right, so that's it for lesson 3.3. In our next lesson, we're going to be talking about how to round decimals to specific place values. So until then, I will see you soon.